symmetry. But we can also think about it in terms of reflecting. If you put a negative out in front, what does that do to our graph? Because it's like taking your y's and changing their signs. So 0, 0 won't go anywhere. 2, 6 would go to 2, negative 6. 7, 6 would go to 7, negative 6. Negative 1, negative 3 would go to negative 1, positive 3. Any point on the axis stays. So our graph looks like this. Okay, so if you reflect it over the x, it's just changing all the y signs. If I tell you f of negative x, so if the x has a negative on it, what is that doing to our graph? Taking all of our points and changing the sign on the x will reflect it over the y-axis. So it's just kind of a symmetry. So if I'm taking those points on the original, negative 4, 0, go to positive 4, 0. Negative 1, negative 3, go to positive 1, negative 3. 2, 6, go to negative 2, 6. 7, 6, go to negative 7, 6. So we're getting this mirror image on the other side. Any questions about that one? Let's take a look at one kind of like we were doing yesterday where we had multiple transformations. It would be a great place to start. What is my parent function? Parabola. We have an x squared. So remember to get those points. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is 1. And 2 squared is 4. So it looks like that to start with. Let's list out all of the different transformations that are happening here. What will the negative in front do? Okay. What does the 3 in front do? What does the minus 4 do? And the plus 5. Okay, so we have 4 different things happening here. Some of you might be able to just do the transformation here. I noticed there were several of us yesterday that needed to actually write out some points. So that's fine. That's a strategy I showed you, especially with stretching and shrinking, that could be helpful. These are the points on my graph. So if I just talk about, let's just talk about the first part, the reflecting and the stretching. All there is a negative 3 out in front. If it's outside, it changes x or y. Outside changes y. And it does what it says. So I am taking my y values and multiplying them by 3. Negative 3. So 0, 0, 1, negative 3, 2, negative 12 if you did that point. Negative 1, negative 3, negative 2, negative 12. Okay, that's dealing with the negative and the 3. Now we have to do the other thing. So we have to move our graph right 4 and up 5. And it seemed like when I was going through this, you guys were okay with those. You can move the right and the up without the order pairs, is that right? Okay. So if I take my point, 0, 0 is still at 0, 0. Now I need to do these two things. So right 4, up 5. If I take my 1, 1. It's getting moved to 1, -3. Take that right 4 and up 5. Okay, 2, 4, the 2, -12, that's going to be pretty small. I'm going to go do this one. -1, 1 goes to -1, -3. Right 4. Up 5. So we can see this skinny upside down parabola that's been shifted over. Questions on that one? I'm going to put a graph up here. I want you guys to take a minute, look at it, and see if you can figure out what the equation would be. So we have our graph. Find the equation for that. Can you tell me how this graph has been moved?
Seniors with last names beginning with C through F, please go to the library for pictures. That's last name C through F.
So to move right 3, then we would have to have an x minus 3 in our absolute value. Down 2, we'll put a minus 2 on the end. Okay? So let's look at that. If I took this blue one and moved it right 3, down 2. At that point, right 3, down 2. This one, right 3, down 2. Does it match up perfectly?
No, it's been stretched by 3.
Yeah. You notice how that red one is skinnier? It had a stretch to it. Couple different ways to figure out what that stretch is. You can do kind of a trial and error and look at it that way. We could think about, you know, if I moved this red graph back. Okay, so if I took it back the 3 and up the 2. Right, so if I move this point over 3 and up 2. If I'm trying to move it back to where it was to start with. If I move this one. This is where that graph would have been before I moved it right and down. So is that easier to see that I multiplied it by 3? It had a height of 1. Now it's a height of 3. Okay, you can see this point was 1, 1. It became 1, 3. So that's one way to get the 3 in front. Do you have a question?
Right, yeah, I just counted from the bottom up to 3, which is where it crosses the actual perfect point.
Yep. So you can look here. We know to get from here to here, you went up 3, so it's a height of 3 essentially. That's another way to think about it.
But that would work if it was a fraction, I guess.
Yeah. So
I guess it would.
it
If it's
would.
a small fraction, like 3/4, you could.
Yeah. My suggestion, if I gave you one of those, it might be easiest to just kind of guess and check on that number. You know, see if I multiply it by 2, do I get the right height? If I multiply it by 3, do I get the right height? If you get confused on it. All right, what we are going to do now, I want you to work with other people. That means you actually have to talk to someone.
Oh, my bad. Oh, it's Thursday, man.
I know not everybody's done, but let's go ahead and kind of start talking about it and see how we're doing. Remember, the trick I told you, inside is x does the opposite. outside is y does what it says. So when I see an x plus 4, that's inside, so it's changing the x value of my point, and it does the opposite. What does a plus 4 do to our graph in terms of the transformation? So you do the opposite to your x, so you subtract 4, so it becomes 412. Okay, outside is y does what it says, so the plus 4 would move our graph up 4, so in our point, we add 4 to the y, so 816. Outside is y, so this is a vertical, does what it says, so it's a shrink.
Is compression the same thing?
Yes. So outside changes the y, does what it says. So my y times 1/4, 12 times 1/4 is 3. All right, this one, outside is y, does what it says. So it's a vertical stretch. Does what it says. So I'm going to take my y value times 4. So we get 848. Are we doing okay on these so far? Okay. This one's inside. Inside is x, so it's a horizontal. Does the opposite, so multiplying by 4 will shrink. Okay, says the opposite of what it says. So I take my point 812, and I have to divide my x by 4, so it becomes 212. Alright, this one, inside, so horizontal. Does the opposite, so it's a stretch. So if I take my point 812, inside changes the x, does the opposite. Opposite of multiplying by 1/4 is multiplying by 4. So the point becomes 3212. Alright. Are there questions on those? Next ones. You have to have a parent function. I know when you're doing Math Excel, it doesn't have you graph the parent function, but on a test or quiz, that's an automatic point off if you did not draw me the parent function. Also, it does not work if you just sketch a parent function but don't put any points on it. Okay, I have to have exact points, a minimum of 3. So if we think about this, the -2, the negative is going to flip it upside down, the 2 is going to stretch. If you don't like thinking about it that way, just go to your points. Outside changes y, does what it says. So we're taking our y times -2. And you can do extra points if you want. Then, what's the +3 going to do? Okay, so 0, 0 would stay, left 3. 1, 1 goes to 1, -2, left 3. -1, 1 goes to -1, -2, left 3. And that's enough, but if you did more, you would have 2, -4, left 3, -2, -4, left 3. So we're getting this graph. Is that okay? Alright, this one. So, square root graph looks like that, minimum of 3 exact points. The +2 will take our graph. Left 2, -3 would be down 3. So each point left 2, down 3. So that's our final graph. Do you guys know how I got the points on the parent function? I just plugged into our t-chart like x and then square root of x. Step number 4. So parent function, it's an x squared, so that would be a parabola. The 2 on the inside. Inside changes x. Oh, that's not the version you guys have. I gave you guys 2x squared, didn't I? +1. So inside changes x and does the opposite of what it says. So times 2, the opposite of multiplying by 2 is dividing. So 0 divided by 2 is still 0. 1 divided by 2 is 1 half. Okay, 1 divided by 2 is negative 1 half. And then what's the plus 1 going to do? You're looking at a different one. Okay, so I take 0, 0, move it up 1. Okay, then I have 1 half 1, and move that up 1. Take negative 1 half 1, and move that up 1. If you needed, you could do more points. So if we're dividing our x by 2, we would have 1, 4, negative 1, 4. So you could take 1, 4, up 1, negative 1, 4, up 1. So that 2 on the inside is a horizontal shrink. It means I came in from the sides and I pushed it in. So it's getting skinnier.
Technically on these, couldn't you, move your 0 point, like, so this would be 0, 0, but instead it's actually 0, 1, and then you just map off of that based on if 0 was actually, or 1 was actually 0.
Yeah, once you get your first point. Alright. The last ones here, I didn't give you the actual parent function. I told you it's a function with a minus 2 on the end. What would that minus 2 do? Down 2. So you just take a few points on your graph and move them all down 2. So same general shape here. On B, what would that do? Take each point, right. C, there's two things happening. This plus 1 will take my graph, and plus 2, up 2. So I take each point left 1, up 2. And you're just doing enough points so that you can get your graph there. Same general shape. Last problem. What will the minus 2 do? The plus 3. And the negative in front. Over the x. It's making your y's negative. So you flip over the x. So if you have 0, if you're on the axis, that stays. Then I go right 2 and up 3. So this point is at negative 2, 2. If I flip it over the x, goes negative 2, negative 2. Right 2, up 3. This point's on the axis, so when I flip it doesn't go anywhere. Right 2, up 3. Okay, here, I'm at positive 1, negative 2 and a half. So go to positive 1, positive 2 and a half. Right 2, up 3. It's just slightly off my graph. 3, 2, we go to 3, negative 2 when you flip it. Right 2 and up. And that is our final piece. So we have about 10 minutes right now. You guys have the Math Excel assignment that we started yesterday, so that one's due at the end of the day tomorrow. Tomorrow we are working on this again, just more practice with all of our transformations together, so we'll have, some more practice coming.